What's up? What's up? It's your man, Jimmy Chan. All right, so now we're talking about discrete random variables. So random variables, there are two different ones, right? There's discrete and there's continuous. The discrete one has finite number of values, actually countable number of values. Where continuous, there's infinite number of values. So it's not necessarily going to be countable. It's actually going to be continuously random. So it's going to continuously go on and go on and go on. So for us, we're going to mainly focus on the discrete, the countable ones, the finite ones, okay? A probability distribution of a discrete random variable x provides the possible values of the random variable and their corresponding probabilities. A probability distribution can be in the form of a table, graph, or mathematical formula. The rules for a discrete probability distribution is the fact that the sum of all the probabilities have to equal 1, and each individual probability has to be between 0 and 1. So let's take a look at these three examples here. So let's look at A. So when we look at this, we find an issue, and that's this one right here. And because that this probability is less than 1, right? It's not between 0 and 1. This is not a discrete probability distribution, okay? On the second one, everything looks normal. It looks like every single one of these are between 0 and 1. However, the only way to find out is if we just add all these numbers together. Plus 0.1, plus 0.14, plus 0.49. Well, the sum of the probability is going to come out to be 1.18, which is definitely an issue as well, right? So therefore, this is also not a probability distribution. How about this last one? Well, let's see, the sum of this is going to equal to, let's see, 0.2 plus 0.25 plus 0.1 plus 0.14 plus 0.31. Ooh, that is equal to 1. So yes, this is a probability distribution. Okay, meaning that each individual one is between 0 and 1, and the sum of all of them is equal to 1. So this one is, all right? All right, so let's take a look. Now, with this being said, with these tables being given, I can find the mean of it by summing the product of x times the probability. When you take the product of x times the probability, that's also known as the expected value. Just so you guys know. All right. And we also can find the standard deviation. Now, there's two different formulas here for standard deviation. They're both going to give you the same exact thing. So we're going to go ahead and do all three of these, just so that you can know how to find the mean. And then for the standard deviation, we're going to do both so that you guys can actually see which way you guys would prefer to do it. So this way I can explain all the possible bumps in the road, right? All right, so for the example, find the standard deviation. Well, we're going to find the mean and the standard deviation of table 1 here. So the first thing I got to do is add these up. These all are between 0 and 1, so that's good. So let me see here. I got 0.01 plus 0.1 plus 0.38 and plus 0.51. Yep, that is equal to 1. So this is a discrete probability distribution. That's good. So now let's go ahead and start putting some of these things into the table. So my x values are 0, 1, 2, 3. That probably was 0.01, 0.10, 0.38, and 0.51. All right, so now let's multiply them, right? I'll do the first one, no problem. 0 times 0.01. 1 times 0.10 would be that. And then this would be 0.76. And this would be 3 times 0.51 is going to be 1.53. So what this is telling me is first I got to find a product of each one, right? Of each of these two. And then I have to sum them. So that means I got to add those all together. So I got to add the 1.53 with the 0.76 and then add it to the 0.1 and add it to the 0. And what I'm going to get here as a sum is going to be 2.39, and that's going to equal to my mean. Okay? All right. So let's go ahead and copy that down here because we're going to do the same thing here. 0, 1, 2, 3, 0.01, 0.10, 0.38, and 0.151. And then I got the 0 here, 0.10, 0.76, 1.53, and this is going to be 2.39, which is equal to my mean. Okay? All right, so now over here on top, I decided I'm going to do this very first thing to see what that looks like, and then we'll do this one here and see what that looks like, and then you guys get to decide which one you want to use. Okay, so here what I'm going to do is, just because I don't want to like really force my eyes to go in different directions, I'm going to go ahead and just put them side by side so it's easier to subtract or whatever, right? So this one is just the x values, which is the 0, the 1, the 2, and the 3. The mu we found, and that's going to be the same answer every single time, 2.39. Okay. Then we're going to subtract these two. So 0 minus 2.39 is going to be negative 2.39. 1 minus will be what? Negative 1.39. And then 2 minus will be negative 0.39. And then 3 minus is going to be 0.61. All right. So 0 minus 2. Okay. All right. So now I got to square these. So let's see here. Negative 2.39 squared. I get 5.7121. $1.9321. 0.1521 and 0.3721. So that's squared. And now I gotta multiply by the p, which the p was already given originally. So let's just write those down, which was 0.01, 0.10, 0.38, and 0.51. All right, so now I gotta multiply these two, right? Okay. So since I have this one up already, let's multiply that by 0.51. I get 0.189771. 0.1521 times 0.38. I get 0.057798. I get 1.9321 times 0.1, that should just move the decimal place. And this one should just move the decimal place twice. Okay, so now I got to add them all together, right? Because it's telling me to sum them. So now I'm going to sum that. So add that to 0.19321 plus 0.057798 plus 0.189771, and that's going to equal to 0.4971. Okay, so this is equal to the variance. That's equal to the variance. Okay. So the standard deviation will be the square root of that, which is equal to 0.7056. Okay. So that's the standard deviation. And this over here is my mean. All right. So no matter how you do it, there's only one formula for mean, so you're going to get the same mean over here. Okay. So you're going to get the same mean over here. But the question is, would I get the same standard deviation if I use this other formula, right? So there is a second formula here. So let's take a look if this would be easier. Number one. Number two, would it give me the same thing, right? So let's take a look at this. I know that right now we're doing a little more work, but at least we're trying to test it out so that we can say, I like this way better, right? So first thing I asked for is x, which I already know. That was part of the given. So let's square this. So I got 0, 1 squared, 2 squared, and 3 squared. P of x I was also given, which is 0.01, 0.10, 0.38, and 0.51. So now I got to multiply those two things together. Is that right? Okay. So 0 times 0.01 is 0. 1 times be 1, 0. 4 times 0.38 is going to be 1.52. And 9 times 0.51 is going to give me a 4.59. Okay, so now I have to sum that. So when I add those all together, let me see, plus 1.52 plus 0.1 plus 0 is going to give me a 6.21. So this is equal to just this, just this piece right here. All right, so that's this piece. Okay, that's the sum of that. Then it says to find the standard deviation. Well, let's do it as find the variance first, right? So the variance, which is sigma squared, would equal to just this piece here, right? Everything under the radical. Excellent. And I already have the summation, so that's going to be sigma squared is equal to 6.21 minus the squared of the mean. So I got to do 2.39 squared. Okay, so I got to do 2.39 squared. So I have 6.21 minus 5.7121. So So sigma squared is equal to 0.4979. A little different, right? So let me take the square root of that. I get that the standard deviation is 0.7056. So if you notice that, yes, the variance was a little different. However, when push comes to shove, the standard deviation was still the same. Okay, so it doesn't matter which way we do it. The question is, which way is better for you, right? Which way do you prefer it to be? So that is totally up to you of what you want to do. I'm just going to move this around so that you guys can see. You know what? Let me just do this. Variance equals this. And let's put... I'm going to put a big fat line right here. And then right here. And then right here. Okay. And what I'm going to do is going to take this. Okay. This way you can see it's two different methods there. Okay. And then the last thing I want to hit on is, what if they gave you a frequency table, right? So this is giving me X values and a frequency. How would I construct a discrete probability distribution? Okay. So to do this, first thing I want to do is see, okay, how many total things do I have here? So I'll do 16 plus the 18 plus the 18 plus the 43. And what I see is that total, there is total of 95 items there, okay? So my sample space is 95. So what I want to do is to extend these right here to become probability. What I would need to do so for me to find the P of X, the probability, I would have to do the 16 divided by the 95. And I'll get 0.1684. Then I'll do the 18. So I'll do the same thing for every other one as well. So 18. So 18 divided by 95, 0.1895. And the same for the next one. And then the 43. Four, 5, 2, 6. Now, if I add all these numbers together, I should get a 1, right? But first, let me do this. Actually, no, let me do this. Duplicate this, bring this to where I want it to be. That looks good right there. Then I can extend these to that. There we go. go. So that is how I want to go about finding the distribution, right? The probability distribution table. Now from here, if I add these up, that should equal to 1. That's number 1. Number 2, and it's always good to check. You know what? Let's go ahead and check that anyways, right? So let me see. 0.1684 plus 0.1895 plus 0.1895 plus 0.4526. Ooh, that it's just 0.1684 plus 0.1895 plus 0.1895 plus 0.4526. It does equal to 1. So there we go. So that will help you also to check to make sure that you have the right math. And typically we want to go to 4 decimal places. Now from here, if it asks you to find the mean and the standard deviation, you can. You will just use one of these 2 formulas. Well, one of these 2 formulas for standard deviation and that for the mean, right? So don't forget that this right here is the standard deviation. Okay? So that means right here, same thing. This is the standard deviation. Okay? And this is the variance. All right? And there you go. I hope that answers all your questions. Any questions from you, please let me know. See ya. Bye.